With this probability one, we are looking at the number of employees that will call in sick, the probability of it. So the question states the probability that an employee at Acme Food will call in sick on Tuesday is 0.05. Okay, so the shipping department has same probability for the shipping department. Shipping department has 9 workers. What's the probability that 2 or more shipping workers will call in sick on Tuesday? So this can be 2 of them, 3 of them, 4 of them, 5 of them, all of this. We can add up each one of them individually. We can find out the probability of 2 of them, add that to the probability of 3 of them calling in sick, add that to the probability of 4, all the way to 9. We can do that, and that's a lot of work. But there's an easier way to do it, and the easier way to do it, remember that probability, the maximum amount that we can have in probability is 1, indicating 100%. But so 1, what we can do is find out what the probability is that 0 call in sick and that 1 call in sick, because that's the exact opposite of 2 or more. And then we can subtract that from 1. So the probability that 2 or more call in sick is equal to 1 minus the probability that 0 call in sick minus the probability that 1 calls in sick. Alright, so what we're going to do is determine what the probability is that 0 call in sick, and then determine what the probability is that 1 call in sick, and then we're going to subtract both of those from 1. Okay, so we'll need to know what our P's and Q's are. Remember, we're going to use the binomial probability formula. In fact, let's bring that in right now. Here's our binomial probability formula. We have a combination here. We've got P's, Q's, N, and R's. Let's identify what these P's and Q's are first. P is the probability that someone is actually going to call in sick. This is the probability of success, okay? Success would be the probability that someone calls in sick, because we know what that percentage is. What that probability is. It's 0.05. And Q would be the probability that they do not call in sick, which would be the inverse of this one, not the inverse, but the 1 minus this. So it would be 0.95 probability that they will not call in sick. Okay, so we're trying to again determine the probability that 0 call in sick. So our R value is going to be 0. The success is we want 0 to people call in sick. So 0 would be the number of successes. N would be the number in our study here, which is 9 workers. Okay, so 9 different ones. So let's find the combinations here. We've got 9 choose 0. So we'll do that. 0 call in sick. This is 9 choose 0 times the probability of success, the people that call in sick. 0.05 is our success rate of people that call in sick, which would mean the probability of failure would be the people who don't call in sick. That would be 0.95. And this is raised to the number of successes that we want. In this case, we want 0 people to call in sick, so we'd have 0 here. Okay, that's directly from our R value. The probability that we have the probability that we don't have anyone call in sick, that is going to be our N minus R, which is 9 in this case. Okay, 9 is our N, R is 0, so that's just plain old 9. So now we can plug that into our calculator right now, and it would give us this as the answer. Now, if you want the shortcut to this, if you notice here, this is 9 factorial. 0 factorial is the same thing as 1. 9 minus 0 factorial is just 9 factorial. So we have a 9 factorial over 9 factorial. That's just 1. And then anything raised to the 0 power is 1. So what we could have done, the shortcut would have been 0.95 raised to the 9th power is this number right here. That's if you want to do the shortcut. You don't have to. You can plug it into this formula and it works every time. Excuse me. Okay, so now that's the probability that 0 call in sick. We need to determine the probability that 1 call in sick. 1 person calls in sick. Okay, so the P value and the Q value are all going to be the same. The P value is still going to be the probability of success, which just means that people call in sick. That's 0.05. And Q is the probability of failure, which is the probability that they don't call in sick, 0.95. That won't change. Our R value does change on this one because we want 1 success. We want 1 person to call in sick. And so now we're just going to plug this back into our formula here. The probability that 1 calls in sick. This time it's going to be 9 choose 1 call in sick. And that's going to be multiplied by the probability of success. In other words, the probability that someone calls in sick, that's 0.05. We're going to multiply that by the probability of failure. In other words, someone that they do not call in sick, which is 0.95. This value here for our success rate now is going to be 1. Instead of 0, now we're going to have 1 person call in sick, which would make this would be 9 minus 1, which would be 8. These two numbers here, these two exponents always have to add up to this N value, this 9. So this is 8 and 1 is 9. 9 and 0 is 1. So we know we've done that one right. We just plug this one into our calculator right here, and we get this as our answer here. I notice I haven't rounded these yet. Typically, you don't want to round until you get right to the end. Okay, so now we know the probability that 0 call in sick and the probability that 1 calls in sick. Okay, so now in order to find the probability that 2 or more, we just subtract. We go 1 minus this probability minus this probability. So let's do that now. We've got 1 minus this probability that 0 call in sick. And then we're also going to subtract the probability that 1 calls in sick. And this will give us our answer. Our answer here, now we can round it. We round it to the nearest 6 decimals. That would be 0.071211. And that is our total here possibility that 2 or more will call in sick. Very low probability that 2 are going to call in sick, and mostly because we have a 0.95 chance that they will not call in sick at all. So 2 or more is very unlikely.